reinforced concrete structures. So we're only going to focus on reinforced concrete structures lang. Okay? So it is important for us to know, okay, or to consider earthquake in terms of the design of a particular structure. This is for the structure to maintain its integrity and to safeguard the occupants of that particular structure. Okay, so these are your earthquake loading requirements in determining the earthquake loads. So this is not a step-by-step process. Okay, this is not a step-by-step process. This is only the requirements. Okay, kumbaga summary of the requirements for the earthquake load. Okay. So first requirement is that identify the maximum considered earthquake. Okay. So ano ba tong maximum considered earthquake na to? Ito guys, yung records ng ating earthquake. Okay. So well, an earthquake can induce a force, okay, on a structure, and these forces are based on the maximum considered earthquake, or your MCE. Okay, so this is an extreme earthquake considered to occur only every 2,500 years. Okay, so every 2,500 years lang siya occur. So yung severity ng MCE level ground shaking is actually described, okay, in terms of the spectral response acceleration parameters, which is your SS and your S1. Okay, so makikita kayo later on, SSS1 na yan, katulad dito sa table na to. So ano ba yung mga yan, malalaman nyo later on. Okay, so yung SS and S1 na yan, okay, yung mga values niyan ay nakasaad sa ating ASCE 7. Okay, ASCE 7. So parang contour map yun guys. Parang contour map yun na nagpapakita sa inyo kung ano yung value ng SS and S1 at this particular place. Okay? And available din yan, okay, sa ating free box. Okay, sa ating free box. But since we are using ASCE 7-16, where you can find the contour map, okay, sa website ng USGS or the United States Geological Service. Okay? So yung parameter na SS is a measure of how strong the MCE affects in the structure, okay, during a short period, probably mga 0.1 or 0.2. Kasi we're measuring the strength of an earthquake depending on its magnitude and intensity. Okay, so normally, kumukuha lang tayo ng a portion of a second, okay, in measuring. Okay? Ngayon naman, yung S1 is a measure of how strong the MCE affects structures with a longer period. Okay? So, pag kinukuhanan mo na ng mas mahabang oras, okay, yung magnitude and intensity ng earthquake, okay, yun na po yung ating S1. Okay, so 1 second and greater than, probably greater than or equal to 1 second ang period na kinukuha natin. Okay? So yung mga spectral response parameters na yan, SS and S1, are given in the table here. Okay, table D.1. Okay, so we have, the effects of the SS will depend on the site. The spectral response parameters will depend on the site classification. Okay. So punta naman tayo sa soil site class. We also need to consider the effect of the soil class, no? The soil or the classification of the soil in total. Why? Because you know naman when there is a ground shaking, the earthquake tends to disturb the soil underneath a particular structure. So, mas malaki ang settlement na mangyayari and mas malaki ang consolidation na mangyayari. So, may tendency na lumubog yung building ninyo doon sa soil because it's being disturbed, it's being shaken. So, that is why you have to consider your soil site class. Okay? So, yun yung ating soil site class. So, normally, ang classification lang naman ng soil according to table 20.3-1 of your ASE, as you can see in here. Meron lang tayong site class, hard rock, rock, very dense soil, and soft rock. Then we have stiff soil, and then we have soft soil, soft clay soil. And then we have as well soils requiring site response analysis in accordance with section 21.1. Okay? So, huwag nyo nang alalahanin itong mga values in here dun sa second column, third column, and fourth column. Okay? So, ang kailangan lang natin is yung site class. Okay. So, after identifying your site class and your spectral response acceleration, pwede nyo nang makuha yung SMS, okay, SMS, and then yung SM1. Okay. So your SMS is given by this formula. Okay? SMS, FA multiplied by SS, and then SM1 is equal to FP multiplied by S1. So this spectral or this response spectral acceleration, okay, for a short period, that is your SMS. And then yung spectral response acceleration mo naman for longer period is your SM1. Okay, so are we clear with the definitions of your SMS, SM1, SS, and S1?
Yes, sir.
Okay, try to respond as much as you can kasi I am not looking at the Google Meet. So, hindi ko alam kung nakakasunod kayo or not. Okay? Anyway, the calculations, the tawag dito, the PDF file for the calculations will be uploaded through the LMS later on. Okay, so take note of this formulas in here. Okay, so meron naman kayong copy. Balikan na lang natin yan mamaya. Okay, so yan yung SMS and SM1 equations ninyo. Okay, so next naman, ano pa ba? So D1 and D2 or table D1 actually gives you the FA values as well as the FP values. Okay. So, ito yung maximum considered earthquake ninyo, spectral response acceleration parameter. Okay. For short period, yung first, this is used for FA. And then yung second table, this is used for your FB. Okay. So, kung tatanungin kayo later on, what is FA and what is FB? Okay, the values of the FA and FB are stipulated in this table. Okay, so for the FA, i-check nyo muna kung anong site class yon, and then check nyo yung value ng SS niya. If it is greater than 1.25, of course, site soil class C, malamang 1.0 yung magiging FA. Okay, for FB naman, we have here, identify the site class, and then kung anong value ng S1. Okay? So, ito yung magiging values ng FA and FP nyo respectively. Okay, so those are your site coefficients. Okay. So, meron din tayo guys, formula earlier, which is ito ata, SDS and SD1. Okay, that's equal to 2/3 ng SMS and then lang 2/3 ng SM1. Okay? So, ito naman yung inyong tinatawag na Design Spectral Acceleration parameters SDS and SD1. So, this is another group of spectral acceleration parameters. Okay? So, i-check na magagamit natin yan later on. So, it is just a portion of your SMS. Okay? Or your SM1. So it depends. Kung SDS, it's just 2/3 of your SMS, and SD1 naman, that's just 2/3 of your SM1. Okay? So any questions so far? Okay. Now let's next table that we have in here are the risk importance factors. Most of you already know what a risk important factor is. Okay, so kailangan kasi natin i-categorize, no, kung ano yung gaano ka-importante yung building, especially if it is an essential building. Now, hindi common na to sa inyo guys kasi we already used this way back when we computed for the wind loads. Okay? So we have different risk categories, 1, 2, 3, 4. Okay, and then we have their corresponding importance factor. Okay, take for example a hospital, diba? So during an earthquake, a hospital should be fully functioning and stable. Okay, after an earthquake, still the hospital should be fully functioning and stable. Okay, out of all the buildings out there, it is the most important buildings are those buildings that are able to provide um, utilities, okay, and then healthcare, mga ganyan guys. Okay, so we have the service utilities and healthcare. So another thing siguro is like a fire station is also of great importance kasi what if nagka-earthquake, malamang there are chances na magkakaroon ng sunog din because magkakaroon ng kumbaga may mga electrical malfunction, mga ganyan. So nangyayari din yun during an earthquake. Okay? So may masusunog, mga ganyan. So kailangan talaga i-design ang mga buildings na tulad nito, okay, ng kumbaga may special na importance or kumbaga special treatment. Okay? So we have the risk and importance factors. So babasahin na lang natin yan later on if the building is of great importance, okay, or really an essential facility, it is risk category 4. And the corresponding seismic importance factor is 1.5. Okay? So yun yung ating seismic importance factor. Okay. So we also have the seismic design categories. Okay. So ito yung mga the seismic design categories are assigned using this table, which is table D.3. Okay. So meron tayong seismic hazard. It actually depends on the seismic hazard level, the soil type, risk, and then kung anong use niya. Okay? So the seismic hazard level also depends on the geographic location of the structure. Okay? So kung ang S1 mo is less than 0.75, the seismic design category can be determined from table D.3. Okay? For letter A, kasi dalawa yan, we have table 3, D.3A. Okay? So, ito, alone where certain conditions apply. And then yung B mo naman give different results for the same structure. The more severe SDC is used. Okay? So, it really depends. So, if you're going to use your SDS, okay, so you have to identify first kung anong risk category. So, you have to identify as well the value of your SDS. Okay? So, if your SDS falls at exactly 0.50, kunyari this category 4 ka, so you're going to use an SDC or your seismic design category as D. Okay. What if greater than 0.50 siya, guys? Kasi in here, we don't have a parameter wherein the SDS is greater than 0.50. Tama ba? So, anong gagamitin natin this category? What's the risk category that we're going to use if your SDS is greater than 0.50?
Yun ang mismo, sir. 0.50.
0.50. Okay, so if your SDS is greater than 0.50, guys, okay, the question lang kasi dito is kung anong risk category ba yung gagamitin natin. Okay, so ganito yon. Hindi natin ililimit yung value ng SDS natin na 0.50. For example, 0.75 ang lumabas. We will use as it is yung value ng SDS. Pero yung risk category mo will be the maximum risk category. Okay? So, if your SDS is greater than 0.50, you're gonna use category D. Okay? Category D. Okay? Paglagpas na siya ng 0.50. Similarly, that can be applied as well kapag yung SD1 mo naman is greater than 0.20. Okay? If your SD1 is greater than 0.20, you can use risk category D. Okay? So after determining your SDC or your seismic design category, you can now proceed with calculating the seismic design loads. Okay, the seismic design loads. For the vertical forces, or definitely that's your gravity loads. Okay, syempre may ini-induce din kasi guys na it is presumed that hindi lang lateral forces ang ini-induce ng earthquake, but also vertical forces. Okay. So in here, your vertical forces will be equal to 0.2 multiplied by your SDS multiplied by your D. Ano ba yung D dyan? What is D? Okay. Your D is actually equal to your dead load. Okay. Your dead load at that particular level. Okay. So that's 0.2 SDS multiplied by your D. Okay, so that's your vertical forces. Pero ang pinaka-importante in here, guys, is actually the calculation of your lateral forces. How are you going to calculate your lateral forces? Okay, it really depends. Okay, kumbaga, it depends on the value of your CS. Okay, so your lateral forces can be, okay, Fx equals 0.01 multiplied by Wx, wherein yung Wx mo is the portion of the dead load of the structure D located or assigned to level X. Okay. So, kapag yung structures mo, guys, okay, na may seismic design category A, okay, yan, pwede mong gamitin yung Fx equals 0.01. Okay, that is for the case only of seismic design category A. Okay, SDC A. Okay. Whereas kapag yung inyong category is other than A, okay? So kung meron kang category B, C, D, E, F, kasi yung seismic design category natin from A to F, gagamit ka na ng equivalent lateral force procedure. Okay, there are other methods in calculating for the lateral loading of SDC B to F, pero we're just gonna focus on the easiest one, okay? The equivalent lateral force procedure, okay? So dito na kayo nag-i-introduce ng base shear, okay? Or your base earthquake shear, okay? At the base of the building. So have you ever encountered base shear in your earthquake engineering before? Naka-encounter na ba kayo ng base shear? Hindi pa? Hindi pa kayo naka-encounter doon? Alam mo, nakakagulat kapag pumapasok ka. Feeling ko parang nakakagulat ka. Hello, anyone? It's a simple yes or no question. Have you ever heard of base shear? Hindi pa? Sinong earthquake engineering nyo? Sino? Sino yung ganun nyo, earthquake engineering nyo? Sir Darrell. Hindi niya in-introduce sa inyo kung ano yung calculation ng earthquake loading?
I-introduce you.
Oh, have you ever heard of the base shear? Naalala niyo pa ba or nakalimutan niyo na? Hindi na, nakalimutan niyo na. Okay, I will ask Sir Darrell later on kasi dito lang naman siya if naituro ba niya yon or not. Or kung naituro naman niya, baka nakalimutan niyo lang. Okay? Ngayon guys, by the way, hindi na ako nag-intro guys kung ano yung magnitude, ano yung intensity, ano yung tawag dito, epicenter, focus, mga ganyan ng earthquake, okay? So, kasi understood na alam nyo dapat yon. Okay, so hindi na ka nag-intro ng ganyan. Okay, pero baka makasama siya sa exam niyo later on. Okay, sinasabi ko lang. So, you have to do reading naman since bibigyan naman kayo ng ample time, okay, to research and read on your own. So later on, huwag kayong reklamador. Okay, reklamo kayo ng reklamo. Okay, nainis na ako sa mga nagre-reklamo na ganyan. Puro sila reklamo. Okay, so huwag kayong masyadong nagre-reklamo, guys. Okay, huwag masyadong feeling entitled yung iba sa inyo. Okay, hindi pa kayo engineer, ganyan na yung ugali. Okay, so going back, we share. So, through the use of your equivalent natural force procedure, ha? Ano pinagsasabi mo? Iba to. Parang YouTube ad. Glacier. Glacier ka dyan. Okay. So, ayun. Pagpasensyahan nyo na. Nandito kasi ako dun sa... yung boss ko kasi nandito eh. Okay. So, this is your formula for your base shear. Okay, so what we have in here, V equals CS multiplied by your W. So your W is the effective seismic weight, and your CS is the seismic response coefficient determined in accordance with ASCE SEI section 12.8.1.1. Pero in our case, this formula was taken from ASCE 7-10. Yung ginagamit kasi natin is ASCE 7-16. Okay? Upon checking, 7-10 and 7-16, wala namang nabago. Okay, so we're gonna use this formula. Okay. So, wala tayong problema with the calculation of your effective seismic weight because that's just equal to the weight of your level. Okay, level. So, mayroon lang tayong problem with determination kung ano ba gagamitin ng CS, kung ano ba gagamitin ng CS. Okay, so we have here the standard formula for your seismic response coefficient is equal to SDS all over R all over IE, or that's equal to your yung R ninyo dyan, I think that's reduction. Wait lang. Kumbaga para siyang reduction factor. Pero you will encounter that later on, okay? So your R is actually your reduction or your response modification coefficient, okay? So that's your response modification coefficient or your reduction, earthquake reduction. Okay. So yung CS natin, madami ang formula. Okay, the value of the CS actually depends on the value of your T. What is your T? That is your fundamental period. Okay, so your T is your fundamental period. There is a kumbaga, importante guys na i-calculate natin yung ating T. Okay, yung ating T. So, standard formula natin itong nauna, pero we have to check the value of your CS, okay, with respect to these two. Okay, so we have to check the value in terms of these two, pero ano ba dito yung pag-checkan natin? To which value are we gonna compare? That depends on the value of your fundamental period. Okay, so we need to calculate our fundamental period first. Okay. So if your fundamental period is less than or equal to the period which is given in the ASCE, you're gonna compare it, your standard CS formula will be compared with your second CS. Okay, then yung equation 12.8-3.
Yes, sir.
Ngayon, if yung value ng CS should not be greater than the value of your CS in here. Okay, so yung 12.8-2 ninyo, yung value niyan should not be greater than the two succeeding values of this given equation. So yung 12.8-2 dapat mababa yan compared sa 8-3 and 8-4. Okay? So in our case, CS permitted to be less than 0.044, i.e. SDS, or less than 0.01. Okay? So yun na lang yung magiging kumbaga yung magiging remarks natin, okay, ng CS. Okay, so hindi dapat siya bumaba sa 0.044, i.e. multiplied by your SDS or less than 0.01. Okay? Okay, next. When you are given the value of your S1, okay, when your S1 is greater than or equal to 0.6, of course, you have to check this equation. Okay, so CS mo will be 0.5 multiplied by S1, and then divided by the ratio of your R and I. Okay. So wala tayong problem sa CS kasi that's just basic formula. Okay. So the value of the CS will depend on the value of your T. Okay. So let's move on to the fundamental periods. Okay. So we have in here TA, mga ganyan. So we have two values of TA in here. These equations actually gives you the values of the fundamental period. Okay, so we have the first one, the actual fundamental period is equal to CT, okay, HN raised to X, and then PA equals 0.1 N. Okay, so tatanungin nyo, baka matanungin nyo, sir, which value are we going to use between the two? Is it 8-7 or 8-8? Okay, ganito yan guys. Take note that yung fundamental period ninyo, that depends on the height of the building. Okay, gaano ba magdadrift yung building? Okay, gaano katagal magdadrift yung building? So, it depends on the height of the building. Ngayon, the first formula in here will be used only if your story level exceeds 12. Okay, so kapag ang levels ng inyong building is greater than 12. Okay, kumbaga 15 floors yan, 16 floors, 13 floors. Yung TA na first, yung formula ng TA first, okay, yung CT, yung TA equals CT, HMX, yan yung una, yan yung gagamitin niyo. Okay? Ngayon, kailan naman gagamitin yung TA na 0.1 times N? Gagamitin niyo yan guys kapag yung inyong story level is less than or equal to 12. Okay? And at least yung inyong story height or yung height ng isang level is greater than or equal to 12 feet or 3 meters. Okay? Hindi ko na siya nilagay dito ha. So you just write that later on. Okay? Kung kailan gagamitin yung TA na to and kung kailan gagamitin yung 0.1. Okay. So your fundamental period is equal to 0.1 multiplied by yung malaking engine, guys, that is the number of story. Okay? In the first formula naman, yung CT natin dyan is actually a coefficient. Okay? So I will be giving the coefficients later on. Normally, guys, yan ay equal to 0.016. Okay? That is in terms of the English unit, and 0.0466 naman yan in terms of the SI units. And then yung X nyo dyan, that is equal to 0.9. Okay? That is only considering concrete moment resisting frames. So those are just the standards for concrete moment resisting frames. Pero kapag yan ay steel moment resisting frame, ibang usapan na po yun. Okay? So once you have the value of your fundamental period, you can now check for your CS. Okay? And then once you got your CS, okay, makakompute mo na yung base shear. Okay, makakompute mo na yung base shear. Now, upon computing the base shear, you can now get the lateral force in each level, applying this formula. Fx equals CVx multiplied by V, wherein your CVx is equal to the weight of your floor level multiplied by the height from the ground level of that particular floor raised to K all over the summation of your WI, okay, the weight of that particular level multiplied by the height of that level. So, i-add mo guys yung mga nasa baba niya. Okay, so makikita nyo later on kung paano gamitin yung formula na to. Okay? So, meron din tayo, so far, nakaka-follow ka ba or not? Can you still follow? We're still discussing lang naman the formula. Okay. So, very good. Please respond lang kayo kung may tanong ako. Yes or no lang naman yun. There's nothing wrong with that. Okay. So, these are now your response modification coefficients. Okay, so ito yung mga values ng R ninyo. Okay, we have moment resisting frames, ordinary reinforced, and then we have special reinforced concrete frames, yung mga ganyan. So identify nyo lang dito later on kung anong type ng building framing system yung ginamit. We've already discussed the framing systems, right? Structural systems, tama ba? You still remember? You still remember your bearing wall system, then we have the framing system, and then we have the moment resisting uh, framing system. Do you still remember that? Okay, very good. So later on, you identify kung anong type ng moment resisting frame. Eto. Okay. So meron akong kulang dito, guys. I will just modify this one later on. Okay, I will modify this later on. Ha? Itong copy na to, kasi nakalimutan kong i-include kung ano, paano nyo kukunin yung value ng K in this particular formula. Okay. And yun nga, ayusin ko ng konti yung ating formulas. Okay? So if you don't have any other questions so far, let's me proceed na lang muna sa example natin. Okay. So, I'm gonna take a quick break muna. Okay. And then, balikan ko kayo. Okay. So, I'm gonna stop sharing my screen before we proceed with the calculation. Okay. Balikan ko kayo later on. Okay. Huwag kayo mag-leave, guys. Okay. Once you leave kasi, huwag kayo mag-leave ng meet kasi baka mamaya hindi na kayo makapasok. Hindi na kayo nagpapapasok ng kung sino-sino pa, guys. Late. Especially yung okay? So, break muna tayo. Balikan ko kayo in 15 minutes. ₱125. Yun.